Hi, this is James Governor from RedMonk. I'm the co-founder. I'm here today with Karen Taggart and Derek Smart, and we're here for a what is, how to video. We're talking what is progressive delivery for database, and basically how you can manage feature flags with databases using Liquibase. So anyway, I guess the first thing to do is to maybe quick intros. So Derek, what's your role at Liquibase?
Oh, hey, yeah. So I'm in the office of the CTO and I do software engineering, just regular old research and development, very heavy on the development.
Awesome.
And
Karen.
I'm Karen Taggart. I'm product owner on the community side of Liquibase. So I get to do open source database DevOps all day long.
So you're closing the loop and he's building the things. That's what we need. Okay, so here's the thing. Progressive delivery, something that a term that I coined. Basically, the idea is it's building on what we've done with CI/CD, but really focusing on some of those other disciplines. So if we think about A/B testing, blue-green deployments, canarying, we've got an abundance of infrastructure today that we didn't used to have. It used to be, we had to, pay for, a bunch of dedicated infrastructure. If we wanted to do, as I say, something like an A/B test, how would we do that? Or we want to do blue-green deployment, the clue is in the name. But increasingly these days, with web infrastructure, certainly we've got much more capability to in order to start saying, wait, we could do things like feature flags. We can make experimentation part of how we deliver applications. We can start to think about doing things like really being comfortable to test in production because we've done dark launches and are much more comfortable in terms of what we're delivering. We're decoupling that deployment stage from release. And that's kind of the core of progressive delivery. Now, as we've seen with CI/CD as well, database seems to get left behind. Yep. So a lot of these new software engineering practices, database gets left behind. And I think the idea of bringing database into progressive delivery is super exciting.
Awesome. Well, that's great. And I'm a big fan of feature flags and a big fan of empowering developers. And then I start to think about when you say things like test in production, which I love. I love that concept. And then I think of a large, say, I don't know, credit card database at a large financial institution and letting developers go, hey, test in production in this huge database of live credit card numbers. And I time out, no, sorry. I'm going to stop the party. That is not a thing. The main reason that's not a thing, and everybody in progressive delivery land gets to have this wonderful ephemeral party all the time, is because the goal is to have stateless applications. Yep. Stateless applications let you roll forward, and in terms we kind of fear in database land, roll back. And do all your ABs, blue greens, canaries, et cetera, et cetera. But when you get into database land, if you start to make breaking changes on a database, and then you have to suddenly roll back because the canary told you no, it's the new version's not right. What do you do and how do you deal with that? And
wait, Karen, are you saying it's bad to lose credit card transactions?
I am. I'm gonna go out on a limb, and not just transactions. I'm gonna say it's bad to lose credit card numbers, actually. And bank account numbers and social security. The reality is that your application code, it's bad when you lose that and break it, and okay, fine. But it's really, 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 really bad when you break the data. So the risk in dealing with database changes is just so much higher. It's because it's stateful, mostly. And so because of that, unfortunately, it's not just a one-to-one that we can just say, take all these great development practices for progressive delivery and just apply them to the database. That's kind of the bad news.
Okay, but
there's good news.
Okay, good news.
There's good news. You can take some of them and you can't take some of those practices, and that's why thankfully we have Derek here who's going to show us how to do that.
Okay, and just in terms of de-risking, I think one of the things is smaller changes. One of the things about the sort of things that we're doing with software engineering now is smaller changes rather than having to batch everything up into one big change. De-risking can be great from a small change perspective. But anyway, let's have a look at what we can do. Derek, and I'd love to see this demo.
Yeah, absolutely, James. And those granular changes you were talking about are the key to doing progressive delivery for database changes, because you don't want to have any kind of schema changes or, table merging or column merging that takes forever to process on a giant database, because that's where you have forced downtime. This is why you have to have data centers open over the weekend, and you've got to have your guys in your Hawaiian shorts and flip-flops doing database migrations at 2 a.m. on a Saturday, because we got to have downtime.
Yep.
But so the idea is taking those granular changes.
Data loss is bad.
Data loss equals bad.
Downtime also bad. So yeah, what can we do that's good?
So by making those changes small and granular, you're able to make sure that they execute in a reasonable amount of time, and can even most of the time can execute on a live database with no downtime.
Mm-hmm.
But as a developer, if I'm working on these database changes, I don't want to have to always be really careful about, okay, I got to push this one in first, and I got to wait for it to be done, and I got to sit there and watch it. Now I got to push this one in because I got to wait for this one to finish before this one goes in. So it's like there's an order of operations to these granular database changes. That's where feature flags really, really come in, because as a developer, they allow me to do all of the work that I'm going to do up all at once, put in the proper feature flags so that, upstream people who are dealing with delivery and deployment can control which database change goes to which database at a particular time. It's not my concern as a developer. This is handled during the delivery phase, and that really helps me decouple that my development of the database changes from delivering and migrating the database changes are completely separate actions and managed outside of the realm of like code changes. Just like if I were to do something like an A/B test, I write the code and the code gets deployed, but which environment has which particular A or B is handled upstream, is handled by an outside, feature flag provider.
Okay, feature flags. Let's see the demo. Let's get to the code. Come on.
Let's do this.
Let's get some developer dopamine going.
I know. Look, I have a flow chart. This is, it's real when you have a flow chart. So in the case of what we're looking at today, we're looking at a real simple pipeline where everything's in GitHub Actions. We're triggering everything from Git. We are using GitHub Actions runners. Liquibase is tying it all together, and we're using a couple of different very common outside cloud providers. All of this is cloud native. We're not doing anything on-prem. Everything from GitHub, HashiCorp Vault, LaunchDarkly, and even the databases are AWS, RDS, Postgres instances. So, but what does that actually mean? So this is what we're going to be doing today. We're going to be looking at what happens when there are changes in Git that trigger a workflow, and Liquibase is going to coordinate that workflow and fetch my credentials from HashiCorp Vault for my testing environment. For the database changes that I have ready to go out, I'm going to look at LaunchDarkly and see which of them can go out for that environment. And then at the end of the day, we're going to have database changes that have happened in RDS Postgres. And that's the same thing with staging. The difference between what's going on in the demo between my testing environment and staging environment is that not all of my changes are ready to go to my staging environment. So even though some of the change log files that we're going to look at, they're exactly the same. The pipelines are the same. The change log is the same. We're going to have different results at the end state on our RDS Postgres because they are different environments and they have different rules and decisions, business decisions were made that said, don't do this in staging just yet.
Okay.
But as a developer, I don't have to care about it. So that is one of the big advantages of being able to use something like progressive delivery and feature flags to enable progressive delivery, is that you can have the same work. As a developer, I'm doing the work once, writing these change log files. And for different environments, for different pipelines, you're going to have different results. And as a developer, I don't really have to care about it, which is kind of nice. So let's take a look at what we're doing. So we're going to actually go through in terms of progressive delivery, there are definitely patterns that help you have zero downtime deployments. One of them is an expand and contract pattern. So what does that mean? It just means that instead of doing like big database changes all at once, where I'm going to create a new field and I'm going to, copy data from one column into this new field, this new column, and then delete the old column, your typical migration scenario, we're going to split those out into granular steps. So we're going to do it. So at first we expand the database by adding new columns. We dump data into it. And then once all the data has been dumped into the new columns, we can say, oh, you know what? Our application is ready. It's looking at these new columns. These new columns are completely populated. Let's get rid of the old one.
That's progressive delivery, man.
That's progressive delivery. Who knew? So in the case of what we're doing today, we're looking at a real simple example of it where I'm creating a table called person. And that person, I'm a developer, and I decided that, the only information we need is where you're going to have their unique ID. We're going to have what state they live in. And I just want their full name, because why would I want their first name? I'm just going to do full name. Turns out product yelled at me at that. So I've got to go back and fix that. So the first things we're going to do is we're going to add some new columns. We're going to add a first name and a last name column. That's its own unique step. Okay. And then once the data from my full name column has been split into my first and last name column, I'm going to go back and drop the column for full name. So that's what's going on here. So that's the demo, and real simple kind of expand and contract use case. Real quick of what the workflows are doing. They are the same workflow, but just using the off-the-shelf Docker container for Liquibase, setting up my credentials and credentials from HashiCorp Vault, telling it which large Darkly environment to use, and then I'm just saying let's run that update. Real simple. Liquibase handles all the logic. So let's do it. Let's click the button. So let's go ahead and run this workflow on my staging my test environment. So let's go ahead and run that. And if I look real quick, let's see if I can beat it. So right now I've got no tables. I'm looking at my dbeaver output. So I've got no tables. And let's let these database changes run. We've got our lovely output, so things are happening.
Yep. Okay.
Now I've got my update was successful. It's about to turn green. There we go. So let's go back and refresh. And if I look at my tables, I've got my database changelog table, which is just the internal database changelog and database changelog tables are how Liquibase knows what changes have been applied without having to do heavy querying to say what's new. So that's why those tables come from. And then look at my person table, and I'm looking, and I am at my final state where I've got my ID, my state, my first name, and my last name. Well, how did I end up here? Because for this particular environment, I was able, all of the flags in Launch Darkly were turned on. So every one of these granular changes were ready to go. So everything got deployed. We got the final state, which is, as a developer, what I'm always trying to get everything to the final state. So this was ready to go. But let's see what our staging environment looks like. So for our staging environment, it looks like we're not ready to contract just yet. So we're going to create the table with state, full name, ID. We're going to add in our first name and last name columns. But you know what? For some reason on the staging environment, our application is just not quite ready to give up that old full name column. Maybe there's some reporting software that hasn't been updated yet that's outside of the application. Who knows? There's a lot of reasons. Maybe the data lake still expects full name to be coming in.
Well, this is a good example too, Derek, of what I talked about: roll forward, roll back. Once you contract, it's really hard to go back. And I didn't mean that to sound as cool and rhymey as it came out, but it's so you can imagine, okay, let's say this is sort of the new version, and I want to have the option to go back if I need to, because again, the canary died. This allows me a little more flexibility to do that if I haven't yet applied that contract.
And in this particular case, luckily, we have a good indicator that the canary is alive because it already ran in our dev environment. So we did deploy all of the database changes, and we could see that they went successfully. But again, being able to make granular changes means you can make granular decisions. So we've got the ability to say, you know what, let's not contract that table just yet. So let's go ahead and do the thing. So let's run this workflow. And it's going to look very similar. It's running the same changelog files. It's running the same workflow. It's pointing to different environments, and all of that's managed by LaunchDarkly. It's managed by HashiCorp Vault. So we're getting different credentials for different databases. We're getting different feature flag values from the flag provider. So all of that's happening on these outside sources of truth. But Liquibase is bringing them all together and figuring out what database changes need to be deployed to which database.
Okay, and some of this is sort of some functionality that were in Liquibase already, but you've been like, how could we apply it? Let's try and understand. Hang on a second, we got this LaunchDarkly thing. So some of this is applying some technology you had to this new use case. Is that right?
Yeah, it is. So in this particular case, one of the things that Liquibase offers is an extension framework, which enables you again, like it says, extension framework. We're able to extend functionality in Liquibase. And one of the things that Liquibase does is a precondition. So in this particular case, if we look here, I have a precondition error.
Right.
That the migration set for the remove full name feature set, the precondition failed. So my LaunchDarkly precondition failed. Why did it fail? Oh, hey, it wasn't turned on. It's kind of what we expect. This is an expected failure. So if I look and I refresh here, we'll see that, no, we've got database changes. So we've got the ID was created, the full name table, the state was created, my first name and last name table were created, but it just didn't contract yet. So we created, we expanded, we just didn't contract it because that's not what we expected to do. But to answer your question, so in this particular case, preconditions are a way to tell Liquibase that only apply these particular changes when this condition is met.
Mm-hmm.
In the case of these new extensions that we worked on for feature flags, that precondition is a feature flag in LaunchDarkly. So we're saying only deploy these database changes when this particular feature flag in LaunchDarkly comes back and says I should do it.
Okay.
Do I have to use LaunchDarkly to act?
No, we've got quite a few. Oh, thank you for asking, Karen. We've got quite a few different feature flag providers, including GitLab, CloudBees, and several of the open source ones like Flagger, FF4J. We've got Growthbook. I forget. They've all got very similar names like Flip and Flagger and Flag.
But basically, you're not trying to own feature flags. You want to integrate with the feature flag platforms in terms of this schema work and what you can do with the database. So you're not, your feature flag system is basically tying into the infrastructure that developers and engineering teams are already using.
That's right. And I think I should be able to pull this up. Let's do this.
Yeah, because part of what we're also trying to do is to, everyone's talking about shifting left, shift left, shift left, which is great. And developers are now supposed to be security engineers and infrastructure engineers. And now we're asking them to be database engineers as well. So it's trying to reduce that cognitive load a little bit by meeting them where they're at, meeting them in the tools that they're already using for other things.
Okay. Oh, my colleague Kelly's going to be so happy that you're showing the documentation with the demo.
Well, we've got great doc people. I write the code. I'm terrible at writing the docs, so I'm always appreciative when I have very, very, very on the ball and talented doc people. So I'm happy to show up their work. But yeah, this is where we get the getting started point. Where you can see which ones are completely open source, which ones require having a Liquibase Pro license. These are the ones, and this is where it's all in one place, and they all work in a very similar way. A feature flag is, when it comes down to it, is a Boolean value somewhere that says yes or no.
Yeah.
So in this particular case, that's how we're using preconditions to say, hey, go look for this yes or no value from this outside provider.
Cool. Did we flip the flag?
Oh yeah, let's flip the flag. Let's do that. Let's fix it. Let's flip it.
End this party right.
Yeah,
right.
Don't leave me hanging.
Don't leave me hanging.
What's
oh
the
my God.
Punchline, Derek.
He's just yeah.
I'm I'm holding like the second to last
Building
note of a
suspense,
symphony.
building suspense. Just
Well, it is.
later.
It is equally important to show that it doesn't, that the no works, as it is to show that the yes
No
works.
is very
So,
important. No
no is
important.
incredibly important. I'm a product owner. We love no.
Yeah, but you're a community person, so you love yes.
Love yes. I know.
It's always good to end on green. So we've got all of our green checks, and that's how I validate my life. It all started in kindergarten. Getting green checks was my goal in life. So now if I refresh, we can see that the full name column is finally gone. We've finally contracted, and now we've ended up in the same final state that we were in our dev environment, where we've got an ID state first name last name, and now we're in an equal state of ID state first name last name.
Yeah, I like this too because, as we know, first names can change. It's just a nice little example there. We can't expect that to be something that never changes. Yeah, cool. So and that was, I think, a very modern example. Obviously, you cover a wide range of databases. In fact, you came out of that world of the more traditional side. But I think that was a great demo using some of the modern tooling. So thanks. That was the what is, how to, progressive delivery, feature flags, the database schema changes, call to actions. Obviously, go to Liquibase, check out the docs if you're interested. Derek and Karen, very accessible people. You can find them on the internet. They're very happy to chat with you about this. So if you'd like to know more, and comment, subscribe, tell us what else you'd like to see in terms of what is how to. Thank you very much again.